Okay, just finishing up the notes from Tuesday. I left off here on number 10. I went ahead and filled it out. So number 10, we have the function f of x equals x cubed. So we find our derivative, which is 3x squared, and the critical number will be at 0. Go ahead and pick a number to the left of 0, we get a positive. Pick a number to the right, we get a positive. And we realize that this function is increasing the entire time. And sure enough, we should already know what the graph of x cubed looks like. It looks like something like that. And sure enough, it is increasing the entire time. Okay, so that's going to lead us into this discovery over here. We're at the top of the notes now on the next page. Let me turn this a little bit. All right, so the function f of x equals x cubed is called strictly monotonic on the entire real number line because it is increasing on the entire real number line. Okay, that function is always increasing. A function is strictly monotonic if it's either increasing on the entire interval or decreasing. It does not have to be just an increasing function. Okay, the function shown here is not strictly monotonic because we do have a part where we are constant right in here. Okay, so not completely monotonic. Okay. After you have determined the intervals on which a function is increasing or decreasing, it is not difficult to locate the relative mins and relative maxes or extrema of a function. Okay. So you can go ahead and read over this, which talks about the very first example we did, number 7, a couple of problems ago. Okay, and it talks about where you actually find those mins and maxes. But we're just going to go get right into it. There's this theorem called the first derivative test. Okay, and here's what the first derivative test says. If f prime changes from negative to positive, then f has a relative min. If f prime changes from positive to negative, then f has a relative max. And if f prime is positive on both sides or negative on both sides, then it has neither a relative min or relative max. So I'm actually going to go back to number 7 first, which we already did. Okay, and we're changing from positive to negative here on this 0. Okay, so based on what the theorem says right here, okay, when we are changing from positive to negative, we have a relative max. Now I like to think of it as a little more common sense type of a problem, and I just think of it like this. Okay, if I'm going from increasing to decreasing, I obviously have a max at the top there, right? So I'm going to say that this is a relative max. If I'm going from decreasing to increasing, I have a relative min on that one. Okay, so you can think of it as either way. Okay, you could memorize this little rule here. Okay, from theorem 3.6, or we could just use common sense. Okay. Positive to negative means increase to decrease, so we are at a max. And negative to positive means decrease to increase, so we are at a min. Okay, so now let's look at number 8. Okay, now this is only telling us the x values, where the mins and maxes are, right? Not the y value. You'd have to plug back in to get the y values. Okay, so on the number 8 here, okay, we're going from negative to positive, or decrease to increase, decrease to increase, so we have a min. And here we're going from positive to positive, so therefore we will have neither. Okay, on number 9, we're going from negative to positive. Okay, so that's going to be a relative min, or decrease to increase. And then we're going to go from increase to decrease, so this is going to be a relative max. And then obviously on the last one here, the x cubed one, we're going from increase to increase, so this is going to be neither a min or a max. Okay, so really we could just find the first derivative of our function, and then it's going to help us out on telling us what's going on. And then right here is just a picture of each one, right? Okay, so you just have a picture of changing to tell you which one you have. Okay, so we're just going to go over to a couple more examples now and fill these out and determine if we have mins or maxes. And once we do this, then you'll be able to do that homework assignment and complete those last few. Okay, all right, so number 11 here. First of all, it says apply the first derivative test to identify all extrema. Okay, so we're just doing this, making a sign table just like we've been doing on these. Okay, so first we're going to find our derivative. F prime of x is equal to 3x squared plus 6x minus 24. And we're going to go ahead and set that equal to 0. Okay, we have a greatest common factor of 3, so I'm going to factor that out and get x squared plus 2x minus 8. And then that's going to factor to x plus 4, x minus 2. And so our critical numbers are at -4 and +2. Okay, so I make my sign table. I got x. I got -4 here. I got -2 here. And then I got my f prime is going to go here and f is going to go here. We know these are zeros. So we're going to pick a number here. We don't need to write the intervals at this point. Okay, we're going to pick a number over here. So let's just pick -3. Okay, so if I plug a -3 into this, that's going to be positive, and that's going to be negative, and a positive times a negative. What am I doing wrong here? Because -3 is not less than -4. Yeah, there we go. How about -5? All right, -5 plus 4 is negative. -5 minus 2 is negative, and a negative times a negative is a positive. So we're going to be increasing on this interval. Pick a number in between, and we get -3. That's where my -3 goes. Okay, and we're going to get a positive and a negative, which is going to give us a negative. So we're going to be decreasing. And then we'll pick a number bigger. We'll just pick 0, and we're going to get a positive and a negative. That's supposed to be positive too. Pick 3. I'm really off my game today. This whole doing Zoom things, or not doing Zoom, and just recording like old school. All right, 3, we get positive and positive, so we get positive and we're increasing. Okay, if we're going from increasing to decreasing, we're going to have a max, and if we're going from decreasing to increasing, we're going to have a min. So we have a local max at x is -4, and a local min at x equals 2. To find the y coordinates, you would plug back into your original and get those values. All right, number 12, and this really is just a mix of different kinds of derivatives for you, okay? Number 12, our derivative is 2/3 x plus 2 to the 2/3 minus 1 is -1/3. Or we can say this is 2 over 3 times x plus 2 to the 1/3. Okay, this function is never going to be 0 because our numerator will never be 0. Okay, but this function can be undefined, and it's undefined when our denominator is equal to 0, and our denominator is equal to 0 when x is equal to -2. Okay, so the only critical number we have is -2. Okay, so I'm going to make my sign table. And remember, we're not 0 here. We are, excuse me, undefined. All right, so we're going to pick a number to the left of -2. Let's say -3. -3 plus 2 is -1. And the cube root of -1 is -1. So we're going to get a negative in our denominator, so the whole thing is going to be negative. So we're going to be decreasing. We'll pick a number bigger. Might as well pick 3. It's the easiest thing to do, or no. Yeah, it doesn't matter what number we pick. 3 will work. 3 plus 2 is 5. The cube root of 5 is positive. We're going to end up with positive over here. And so we're going to be increasing. And so if we're going from decreasing to increasing, we will have a relative min. All right, number 13. Okay, I'm going to write this e to the x in front. I don't like when it's on the back side, okay? So we're going to do first times the derivative of the second. The derivative of x minus 1 is 1, plus the second, x minus 1, times the derivative of the first, which is e to the x. And we're going to set that equal to 0. Okay, I would factor out an e to the x and get a 1 plus an x minus 1. And that really just gives me an x inside, right? So I set e to the x equal to 0, and I set x equal to 0. This will never be 0, but obviously this will. So my only critical number is 0. Okay, once again, we're just picking a number and finding the intervals where we're positive and where we're negative so we can figure out where we're increasing, decreasing, and then determine if we have a min or a max there. Okay, so picking a number to the left, we'll just say we're going to pick negative 1. Okay, e to the negative 1 is positive, e to the negative 1 is positive, but negative 1 minus 1 is negative, and then that's going to be a negative 2 e to the x, e to the negative 1, whatever. That's going to be a negative number. Okay, so that's going to be negative, so we're going to be decreasing there. Okay, picking a number over here. Let's just say we pick 1 will work, right? 1 minus 1 is 0. E to the 1 times 0 is 0, plus e to the 1, which is e. It's a positive number. We're left with a positive number. So we are increasing here. So at 0, we have a relative min. All right, 2 more in this section. Okay, we have the function f of x equals 1/2 x minus sine x on the restricted interval of 0 to 2 pi. Okay, so obviously that's important because it's going to decide where our critical numbers are going to be located. All right, so the first thing I'm going to do is I'm going to find my derivative. The derivative of 1/2 x is 1/2. The derivative of negative sine is negative cosine. And I'm going to set that equal to 0. Okay, I'll add the cosine to the other side. And now we got to refer back to our unit circle. Where is the cosine equal to 1/2? Okay, so cosine is equal to 1/2 at pi over 3. Okay, not in quadrant 2 because cosine is not positive in quadrant 2. Not in quadrant 3 because cosine is not positive in quadrant 3. Okay, but back again in quadrant 4, cosine is going to be positive 1/2 at 5 pi over 3. So we have 2 critical numbers, pi over 3 and 5 pi over 3, but we're only going from 0 to 2 pi. So I'm going to write those numbers in here. Okay, so here we're going to have pi over 3. Here we're going to have 5 pi over 3. And then out here I'm just going to put 2 pi because we're not going to go past there. Okay, those are my x's, f prime and f. I'm not going to test 0 and 2 pi. It's just all of this to the left, but not going past 0. Okay, so hopefully you understand we're not going past there. So this interval here on all the other problems has been negative infinity to whatever my first critical number is. Now I'm just going from 0 to my first critical number. Okay, so give me an angle in between 0 and pi over 3, and we'll just say pi over 6. Okay, so the cosine of pi over 6 is radical 3 over 2, and 1/2 minus radical 3 over 2 is going to be a negative number. Okay, because radical 3 over 2 is bigger than, or radical 3 is bigger than 1. Okay, so that's going to give me a negative number. Okay, again, we're 0 here and we're 0 here. Okay, pick an angle in between pi over 3 and 5 pi over 3. It'd probably be the easiest angle would be to pick pi. Okay, and the cosine of pi is -1, and 1/2 minus -1 is going to be a positive number. So we're going to be increasing. And then we'll pick a number from 5 pi over 3 to 2 pi. We could pick anything, 11 pi over 6, 7 pi over 4. Those are the two memorized. Let's pick 7 pi over 4. Okay, 7 pi over 4. The cosine of 7 pi over 4 is radical 2 over 2. And 1/2 minus radical 2 over 2 is, again, going to be a negative number. So we will be decreasing there. So here we will have a relative min, and here we will have a relative max. Okay, just to reiterate and go over it one more time, going from decreasing to increasing on F is a min, right? Decreasing to increasing, min. Or if F prime is changing from negative to positive, from theorem, I think it was called 3.6. Again, you don't have to memorize the numbers of the theorems, but that says if we change from negative to positive, we're going to have a relative min, and if we change from positive to negative, we're going to have a relative max. All right, last one. Okay, first we'll find our derivative. We have a quotient rule, so it's bottom, x minus 2, times the derivative of the top, which is 2x, minus the top, which is x squared, times the derivative of the bottom, which is 1, all over the bottom squared. Cleaning up the top, that's going to give me 2x squared minus 1x squared is x squared minus 4x. Got to distribute the 2x in, over x minus 2 squared. Okay, now we have a situation where we're going to be 0 when the numerator is 0, and we're going to be undefined when the denominator is 0. So we're going to have several things to check on critical numbers. So I'm going to write it out like this. F prime is going to be 0 when my numerator is 0. Factor out an x. Set both equal to 0, and I get critical numbers of 0 and 4. Okay, f prime is going to be undefined when my denominator is 0. Square root both sides, and you get x minus 2 equals 0, and add 2, and you get x equals 2. So I have 3 critical numbers, 0, 2, and 4. Okay, so I'm just going to make myself a little table, 0, 2, and 4. Have my interval to the left, interval in between. Haven't written it in a while, so I'll refresh your memory. Negative infinity to 0, 0 to 2, 2 to 4, and 4 to infinity. Keeping in mind that at 0 and 4, f prime is 0, but at 2, f prime is undefined. Okay. That doesn't mean that we can't have a min or a max there. It just means we're undefined there. Relative min or max. Okay, if I pick a number to the left of 0, I'm going to end up with a positive. Remember, I'm plugging into my derivative. If I pick a number from 0 to 2, I'm going to end up with negative. Make sure you're plugging in numbers, because typically it alternates, but not always. And in this case, it does not. If I pick a number in between 2 and 4, I again get negative. And then if I pick a number larger than 4, I get positive. So here I'm increasing, here I'm decreasing, here I'm decreasing, and here I'm increasing. Okay, going from increase to decrease is a max. If I do not change signs, or I'm decrease to decrease, I have neither. And then on the last one, I'm going from decrease to increase, so I have a min. Okay, and you could graph every one of these in your calculator, and you could go take a look at the picture and see that we're doing this on all these intervals. You can look up mins and maxes and all that. Okay, but now, unlike before this, there was no other way to find mins and maxes unless it was a quadratic function without your graphing calculator. Okay, you needed a graphing calculator if you had something like a sine curve or a rational function like this, or a cubic function even. We have a basic cubic function like that. We can't find those mins and maxes without calculus or a graphing calculator. Okay, and the calculus is going to be doing it by making a sine table. All right, so just to recap everything and all the relationships that we're going through in this section, okay? And you got to know this, okay? Now, off the top of your head, you got to be able to spit this kind of information out. Okay, when f prime is greater than 0, okay, and that's just another way of saying when f prime is positive, f is increasing. Okay, when f prime is negative, f is decreasing. Critical numbers are located where f prime is 0 or undefined. Okay, not all critical numbers are extreme values. Extreme values mean mins and maxes. Okay, relative extrema do occur at critical numbers, but only when f prime changes signs. Okay, if we do not change signs, we do not change or we do not have a min or a max. Okay, when f prime is 0 or is undefined, okay, f prime is 0 or undefined, and changes signs from positive to negative, that's when we're going to have a maxima. And then the last one, when f prime is 0 undefined and changes from negative to positive, f is going to have a minima. Why did I go all Greek on you? I don't know. That was just what my notes said. Okay, I hope you get these notes and we understand them. And if you have any questions, please feel free to send me a message. And you could go ahead and complete that assignment number 40 now, parts C and D. Part C is just identifying where the mins and the maxes are. So you could just go back in the ones you've done and just write that down, okay? And then part D is you want to try to sketch a graph now that you have this information. You know where you're increasing, you know where you're decreasing, you know your mins and your maxes. Try to sketch a little graph and then check in your calculator to see if your graph is close to what you thought it would be. Okay, good luck with that, and I will be posting the next video for assignment number 41 notes soon.